So in this video, my last one got cut off talking about p53, so let's go ahead and talk some more about tumor suppressor genes. And so p53 is a tumor suppressor gene found in about 50% of human cancers. So p53, when it is, or when the cell is exposed to different stressors, DNA damage, or like oncogenes, anyway, when the cell is experiencing like abnormal conditions where it probably shouldn't divide through the cell cycle, p53 is going to be responsible for producing proteins that are going to stop or inhibit the cell cycle. So that could be, maybe it's just stopping it long enough for DNA repair. Maybe if the damage is too great, it'll cause the cell to go into apoptosis and cell death. So let's go ahead and see how p53 works. So when we have, let's put this here. When there is DNA damage in a cell in G1, you want to not reproduce a cell that has mutations or errors in the DNA. You only want healthy cells to go past that G1 checkpoint into S phase and divide through mitosis. So if there's DNA damage in a cell, that could activate a phosphorylation cascade where that's going to lead to an active form of p53. Now p53 acts as a transcription factor to turn on gene expression to make proteins that are going to inhibit the cell cycle or stop the cell cycle. Now this is good because if the cell has damage in the DNA, you don't want to make copies of that. So the proteins that are made could just stop the cell cycle long enough for there to be repair, or it could inhibit different CDKs in the cell. So anyway, let's go ahead and see what happens. So if there is no p53, that means that there aren't going to be these inhibitory proteins produced. So now there's nothing to stop the cell from going through G1 or the G1 checkpoint. So now the cell is going to divide even with that DNA damage. So p53 is often called the guardian of the genome because it prevents mutations from ending up in daughter cells. So here, if there's a mutation that leads to a defective or missing p53, then the cell cannot make those inhibitory cell cycle proteins. So when we look at how this works, you can see how with DNA damage, p53 is essential to create proteins that stop the cell cycle from going. So when we look at a normal p53, you can see how in this example, it's going to turn on gene expression to make a CDK inhibitor. This blue circle right here, it's going to inhibit that active CDK so the cell cycle doesn't progress, which stops it at that G1 checkpoint, allowing it to repair its DNA and giving it time before it goes into S phase and makes copies of that DNA. Now, if the damage is too great, then apoptosis is triggered and the cell won't go through the G1 checkpoint. However, if p53 is damaged, then there's nothing to stop the cell cycle, and that damaged DNA ends up in daughter cells. So here in a normal p53, up here at the top, you can see how if the p53 protein is working, it can activate DNA repair enzymes. It can activate DNA repair enzymes that allows the cell to fix the DNA before it goes through into S phase. Or it can, if the damage is too great, like I said earlier, it can cause the cell to go through apoptosis. Now, if there's an abnormal p53, there's nothing to regulate this step at that G1 checkpoint, and now damaged DNA in cells can then go through the cell cycle, and that could possibly lead to cancerous cells. So p53 is helps in cell repair. I don't know where to put this, sorry. Shoot. And so if there's minor DNA damage, well then the p53 stops the cell just long enough in order to repair. And if it's like heavy damage, well then that can stop the cell from dividing altogether. And that's just a quick summary on p53.